Imagine you are sitting in the cockpit of an airline. On the outside there's nothing else to see than thick fog and occasionally some rain. The pilots in front of you are not touching the controls at all. Still, they are moving as if an invisible hand was flying the aircraft. Suddenly you hear a computer voice counting down. 500, 400, 250. A line of white light appears in front of the cockpit, and at the same time you can feel the aircraft touching down. The same invisible hand that has flown the aircraft has reduced to thrust. The aircraft slows down, and finally the captain puts his hands on the controls and says, "Alright, let's taxi to the gate." You just witnessed an automatic landing. Automatic landings are common these days. They are used when the weather becomes so foggy that human pilots cannot safely land. Some aviation experts will tell you that in the near future, planes will fly fully automatically and that pilots will not be necessary anymore. After all, if landing is the hardest part of flying, and if airplanes can land automatically, what do you need pilots for? Well, I've been a professional pilot for 10 years now, and I'm asked that question a lot. Today I would like to explain to you why autopilots are not as capable as you might think. There are a lot of reasons why I don't fear to be put out of work in the next 30 years, but here are the most important. Autopilots are not necessarily better or more capable than their human counterparts. They require all systems to work perfectly, they are very expensive, and it is very easy to imagine emergency scenarios which the autopilot couldn't handle. First of all, how good do autopilots fly? Well, they can fly quite well, but only up to a point. It might surprise you, but in some respects autopilots are much less capable than human beings. For example, the operating manual for the Boeing 737-800, a modern airplane, states that the maximum crosswind for an automatic landing is 20 knots, while it is 36 knots for human pilots. If you have a strong wind blowing across the runway, chances are high that the pilots have to hand-fly the aircraft while the autopilot takes a break. Also, everything on the aircraft has to work smoothly. For example, on the 737, the autopilots are not designed to cope with hydraulic system failures, which will make the flight controls much harder to move. A failure of one of the two electric generators will make an automatic landing impossible, while it is just a nuisance to a human pilot. The reason for this is that in aviation you always need redundancies and backups to be safe. If one of the two generators is not working and the other generator fails just when the autopilot lands the aircraft, the autopilot wouldn't be powered anymore and the aircraft would crash. Then there's money. Theoretically, you could design an aircraft with so many redundancies and backups that even if one of the aircraft system fails, the autopilot could still safely land the aircraft. But there's a catch. It will be immensely expensive. For example, to make automatic landing fail-safe, instead of one autopilot, you would need 3 of them. They will check each other, and if one of them disagrees with the other 2, the whole system disengages and the human pilots have to take over. This is why small regional airliners usually don't have these systems. It is much cheaper to divert to an alternate airport, pay hotel rooms for all the passengers, and try again the next day than it is to buy expensive autopilot systems. For fully automatic, pilotless flight, you would at least need 4 autopilot systems to provide the same level of safety as having 2 pilots sitting in the front. Guess what is cheaper? Finally, how well would a fully automatic aircraft do in an emergency? Let me give you an example. In 2001, an Airbus A320 took off in Frankfurt. It had just been in maintenance, and as the investigation report states, the technicians had mixed up some cables. As a result, when the captain pushed the flight controls to the left, the aircraft actually banked to the right. Trying to correct this, the aircraft pushed even more, and the aircraft banked more. This would certainly have led to a disaster if the first officer hadn't taken over in the last second. Luckily, his flight controls worked. The computerized warning system of the A320 had not been able to detect this malfunction, and therefore it is safe to assume that any autopilot system would have flown the aircraft into the ground. As we could see, there are a couple of reasons why pilots are still needed in the cockpit. Autopilots usually work well, but only within the limits, meaning that the weather conditions must be suitable, the aircraft systems working perfectly. Also, all the required autopilot components are so expensive that it is simply cheaper to pay human pilots. Finally, human pilots are much better at dealing with unexpected situations, for example emergencies. Let me end my speech with a little bit of aviation history. According to the book The Quest for All-Weather Flights, the first automatic landing of an airliner took place in 1968. For more than 40 years we have had automatic landings, but there are still pilots in the cockpit. You know why? Because they are needed.